Hello, so this video is a recording of me, just me, going over review number 7. Sorry, third hour, I know we usually record this together, but this is a really long review and I wanted to make sure we got through all of it on one recording. No offense, third hour. Alright, so number 1, these are very similar style problems. This is a repeat standard that we've already tested, but it didn't go very hot last time. So we're going to be solving exponential equations. And we have two options. If we have a common base, which we call the baby base method, I suggest you use it. So 5 and 125, I have the common base of 5. So instead of calling this 125, if you could rewrite this as 5 to the third power, then now you have matching bases, which means the powers have to match. So 9x minus 5 has to be the same thing as a 3. And then we solve from here. So 9x equals 8 and x equals 8/7. Alright, so I like that method. You don't have to use that method. You could always apply logarithms to bring exponents down, but the common bases are awesome. When I look at 2a though, 8 and 10, they don't have any common bases. So in order to bring this exponent down, we're going to have to apply a logarithm or a natural logarithm. And we choose those two types of logarithms because of the quick keys on our calculator's keypad. If I use a different type of logarithm, I have to use change of base method on top of that. So forget that. So for this problem, I'm actually, it doesn't matter, you know, I always like natural logarithm, but you guys seem to like common logarithm better, so I'm going to go ahead and apply a common logarithm to both sides. And common logarithm of 8, nothing exciting happens there except for this exponent's going to come down in front. So we have x minus 7 down in front. Now it's being multiplied by the common log of 8, which is just some gross number, and then equals the common log of 10. Now the common log of 10 is actually a beautiful number, it's 1. But if you didn't recognize that, it doesn't matter because your next step would be to divide by the common log of 8, and this is not going to be a pretty answer, so don't panic. Common log of 10 divided by common log of 8 is, I don't know, something 1.107 or something like that, because my last step is I'm going to have to add the 7 over. So I'm kind of going off my answer and figuring that this is 1.107 roughly. So when I add 7 to both sides, I get x equals 8.107. So last time we tested this, a lot of you had a big issue with what to do, how to bring the exponent down, and you were trying to apply different bases of logarithms, which is a method that does work. It's just not the method that I taught you. So I might suggest that you revert back to using common log or natural log, because if you use a different type of logarithm, then you have to go use change of base formula afterwards, and no fun. So number 3a, we're not ready to apply the logarithm yet because the base is not isolated. So this has to be isolated first. So your first step would be to add the 6 over. So you have 4 times e to the x equals 24. And we're still not quite isolated. Now I have to divide by 4. That says 4. So we have e to the x power equals 6. So now when I go to choose common log versus natural log, this time I'm very happy to say I get to use natural log, and that would be the smartest choice because when you apply a natural log to this equation, not only does the exponent come down, but the natural log of e, that reduces to a 1. So this complete term is gone, and you just have x equals whatever the natural log of 6 is, which I think I wrote that down somewhere, 1.792. There we go. So hopefully you get the idea of how to apply logarithms to bring exponents down now. So the next section, again, an old one from the last test, but we're going to see it again. We need to remember to exponentiate. So a lot of you who missed the boat last time, I wrote some version of this word, exponentiate, or please exponentiate, or something like that, all over your paper. Because if you didn't even know to exponentiate, then we had problems. So the same issue as with the other types of equations, though, we have to isolate the function first. So we have to isolate this logarithm. So we have log of x minus 1, so subtract the 3 over equals 3. And then we had a question very similar to this on the last summative, where a lot of you knew to exponentiate, but you got kind of stuck on this step because you're like, I don't know what to use to exponentiate. Well, remember common log, this is common log, use a base 10. So when I go to exponentiate both sides of the equation, I'm going to raise it up with a 10 as the base on both sides. So what you really have here is now you have 10 raised to the log of x minus 1 power equals 10 to the third power. Well, the reason we did that was because 10 to the common log, these are going to cancel, and the x minus 1 is going to drop down. And then 10 raised to the third power, some of you had trouble with this, like you typed it backwards on your calculator. 10 to the third power is 1,000. So if we add 1, we get x equals 1,001. So same idea, isolate the logarithm and then exponentiate. Nothing really different here, guys. So what's the base of a natural logarithm? That might be a good question for us to answer. So we're going to add the 5 over. So 6 times the natural log of x plus 9 equals 12. Still not quite isolated. Let's divide by 6. And we get the natural log of x plus 9 equals 2. And remember, if you get a jam for log or common log, or natural log or common log, and you forget what the bases are, on your calculator's keypad it tells you what the bases are because they're right above the buttons written in blue. So natural log has an e to the x power in the calculator's keypad written above it, so that means this is a base. It's a logarithm base e. So you shove an e underneath both sides of the equation here. So e to the natural log will cancel, and the x plus 9 drops down. And then e to the second power is, I don't know, something gross. And then my next step is to subtract the 9 from both sides. And we get a really gross answer of negative 1.611, according to my work from before. Unless I made a mistake. It's been known to happen. Alright, so if we're doing this in class, I probably told you guys everything that you need to highlight for factoring, because I think sometimes that's what gets kids tripped up. And remember, you get to use those yellow cards that have steps for you. So the steps that refer to simplifying, which the directions here would say to simplify completely, it says factor everything as step number 1. So I need to factor this and this, and I need to take a moment to make sure that I'm factoring properly. Like if I have kind of sort of the right factoring but not quite, I'm going to ruin the rest of the problem. And you guys are very good at factoring, but you're also a little sloppy on tests, so let's slow our roll a little bit. Alright, here we go. So this numerator factors into x plus 8 times x minus 8. And I know sometimes it's frustrating because your friends are like shouting out factors in the middle of class. You just got to, on a test, stop and think and double check that you're doing this right. So I need to multiply to negative 16. Arches have to add up to negative 6. So how about negative 8 and a plus 2? And then my favorite part, the fruit ninja canceling. X minus 8 will cancel. And we are left with x plus 8 over x plus 2. Now to avoid some embarrassing non-canceling that shouldn't happen, I'm going to put parentheses around each of these polynomials, because these are numbers in themselves. Sometimes I get kids who think things cancel, and we know they don't after this step. This is the final answer. Unless the exact term cancels, nothing going anywhere. Alright, so 7a, 7b, those were the smush problems. So I always instructed you guys to smush them back into one fraction. So I would multiply everything in this numerator together, make a new and improved fraction, which I'm hoping I did that at some point on my work here. Oh, I did. Good job. Alright, so 420 x to the 14th, y to the 2nd. And then similarly, I'm going to smush the denominator together by multiplying all that together. And that is, oh boy, 1, 2, 2, 5, x to the 5th, y to the 12th. And clearly we're not done. This has a lot of simplifying still, but don't overthink this, guys. This coefficient piece, you can divide on your calculator and then hit math, enter, enter. So 420 divided by 1225, that reduces to a 12 over 35. And guys, even I did that on my calculator. I'm not going to do that in my head. Are you crazy? Alright, x to the 14th over x to the 5th. If I subtract those, I get x to the 9th located in the numerator. And then y to the 2nd over y to the 12th. If we subtract those, that's a difference of 10, but it's heavy in the denominator, so y to the 10th goes to the denominator. That is my simplified answer. So don't stop on this question until you've simplified each of the terms as well as after you smush them together. So 8 and 9, I needed to put these on the section to see if you had any clue at all what you're supposed to do. So if factoring is your hang-up, you still have a moment to shine here. So 8 and 9, they're already factored. So as long as you can get around that factoring issue for these two questions, and you can show me you know what to do once they're factored, at least you'll get a 2 on this section, at the very worst. So, and 2's not good, by the way. X minus 1s are going to cross cancel. X plus 3s are going to cross cancel. And if you don't see the rest of the cancellation yet, that's okay. You're about to. I can't really read that, but I think this says x to the 8th right here. So I have x to the 6th divided by x to the 8th. So if you want to cross cancel these right now, you sure can. You're still going to have x squared located down here in the denominator left over. So my numerator doesn't have anything left but the x plus 1, or sorry, minus 1. The denominator now has that x squared that got reduced, and then it also still has this x plus 7. This is the one that had an answer key mistake. If you look on Google Classroom, I took a picture of it and then I was told I had a mistake. Like, big shock, right? Thanks, Lindsay from 7th hour for finding it. Alright, 9a. So again, someone already factored it for me, so if that's my hang up, get over it. Now I have to remind myself what to do when I divide. So remember, we don't divide, we change this to a multiplication problem by reversing and taking the reciprocal of the second fraction. So 32x to the 9th over x times x minus 5 is now multiplied by x minus 5 over 8. So now I can do some major cross canceling, I hope. 32 over 8 reduces to a 4 over 1, which you can always reduce it later if you have a tough time with that part. This is usually the part kids have the toughest time with. X to the 9th over x to the 1st. This is cross canceling to left over x to the 8th up in the numerator. Make sure you keep track of where everybody is. So in your numerator, you still have a 4, you still have an x to the 8th, and there's nothing left in your denominator. So this is a good answer, but if you want to say like over 1, that's okay as well. Alright, so now you get to shine with your factoring skills. So everything has to be factored before we do any sort of cross canceling. So, man, 10 is like a hoot. Everything factors. Ooh, alright, deep breath for everybody. Let's start factoring. Alright, x squared plus 9x. Always, 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 always look for a common factor first. And this has a common factor of x that you need to take out. And sometimes that's all you're going to be able to do, like on that question. That's all the factoring you can do. I really didn't get crazy with my factoring on this test, guys. So it's one of two options. It's either like a traditional trinomial where you have two sets of parentheses, or it's that kind where you take out a common factor. Like those are your only options, so don't panic. X squared minus 10x plus 9. That would factor, I'm going to do another color, try again. That would be x minus 9 times x minus 1. Okay, said it, can't write it for some reason. Gosh, times. This is, let's see, how about 9 and 4? Would that work? X minus 9 times x minus 4. And then my favorite difference of two squares is still going to end up as two parentheses because it's the good twin, the evil twin. Alright, so remember, one term cancels one term. So like this x plus 9 could cancel one of these x plus 9s. It's not going to cancel both. And then this x plus 9 will cancel x plus 9. It looks like that's all that cancels. So there's in the numerator, there's still an x times an x minus 4, leave it factored, over these two. Leave it factored. I know we had some worksheets where the answer keys were all distributed back together because of the computer. I don't want you to do that because that's just another place where you might mess up and there's no reason for you to do it, so don't. Alright, 11 we are dividing, so we'll pay attention to that because we need to switch this around so we can create a multiplication problem, which means I'm going to multitask. I'm going to factor and flip all at the same time. So this has to be factored, this has to be factored, this has to be factored, and this guy has to be flipped around. Alright, here we go. X squared minus 2x minus 8 multiplies to negative 8, adds to negative 2. How about x minus 4 times x plus 2? And don't just assume that you did it right. If you know signs are a weak part of your factoring, stop and FOIL it back together mentally and double check. Alright, remember we flipped this fraction. Oh, that's a common term question. Take out a common x squared. So that's going to leave us with x minus 8. And then multiplies to positive 32, adds up to negative 12. How about negative 8 and negative 4? And remember, there should be canceling. So if you're like kind of stumped on terms and factors, look through the rest of your problem. You should see some repetition of terms. So if you were like 32, like 32 is a weird one because sometimes kids forget factors of 32 because it's got a lot. So, you know, I was thinking about the rest of my question and I saw 8, 2, and 4. That's where my brain went right away. Kind of nice for those of us who struggle in factoring. Alright, cross-canceling now, and then there is some cross-canceling right here and here with the x's. X squared over x to the 5th will leave us with x to the 3rd, but notice it's located in the denominator. So up in the numerator, we have x plus 2, and now I see in the denominator we have x to the 3rd, and absolutely nothing cancels here. X plus 2 does not have a twin, therefore it's staying. Alright, so that's our multiplication, division, simplifying section. Now we're going to talk about how to add and subtract fractions. Remember, you have to have common denominators. So that's where I start. In my list it says factor anything in your denominators that needs to be factored. Well, these denominators don't have to be factored, and it must be like my birthday or something because they already are common. So 5x minus 1 is my common denominator, which means I don't have to do that next step where it says multiply by whatever it's missing. It's not missing anything. So we have 6x plus 3x plus 9. The only thing I can do to make this better would be to simplify my numerator, which is my next step. So that's 9x plus 9 over 5x minus 1. And I'm actually okay with this answer, but you'd be my favorite kid ever if you notice that 9 factors out. If you attempt to factor, that shows me that you really know what you're doing. Okay? And either one of these answers are great. I like that you guys look for factoring at the end, though, because it tells me that you know there might be a chance of something canceling at the very end. All right. Number 13a. I look at my denominators. I have an x, and I have an x minus 7, which are two completely different numbers. So that's what I need for my common denominator. I got to build up an x times an x minus 7 for each fraction. So this fraction is clearly missing the x minus 7. And then this fraction over here is clearly missing the x. I had a lot of you say some weird things to me, like, can I cross multiply this? Can I just multiply this by the other one? No. Because there are sometimes factors that are hidden within other factors, so you really, really need to understand how to get common denominators and how to get the least common denominator and what you're truly doing. Please stop trying to take shortcuts. Breaks my heart. Alright, distributing the 5 here. You get 5x minus 35 plus, this is now a 4 times x, right? So it's 4x. And the next step in my list says clean up that numerator, so this is 9x minus 35, which doesn't factor. That makes me so happy because that means I'm done. If you know your numerator doesn't factor, there's not going to be any more canceling, so life is good. Alright. Okay, 14 looks really unassuming because you're like, oh, they already have common denominators. That seems odd to put in the middle of a section. You're right, it is. Because look at your numerator. I have 9x squared minus 45x. So the child who doesn't think about factoring very much is going to get this one wrong. This numerator factors. And it has a common factor of, let's see, 9x that we would take out. And if I remove a 9x from each of these terms, I still have an x minus 5. See where I'm getting at here? So the child who didn't think to factor the numerator and thought they were safe, you are not safe, child, because look, x minus 5's cancel, and you're reduced down to a 9x. So I'm sure you guys know me a little better than this by now. I'm not going to put like a super easy question in the middle of a section, like just for fun. Also, I'm not going to put a question style on a review and not give it to you on your summative. So you should be anticipating like all these issues that we're running into on the review here. You're going to see them on your summative as well. I write the summative first, and then I go back and write review questions based on the summative. So please keep that in mind. All right, number 15, A or B. They're both great questions, and they're very similar as far as what issues you're going to run into. But the first thing I notice is that the first step in my yellow card says to factor any denominators that need to be factored. This guy right here factors. This is 3x plus 1 times 3x minus 1. That's not legible. Let's try that again. That says 3x minus 1. So those of us who just do that cute little I cross multiply everything technique, you're going to be in trouble on this one. Please don't do that. Oh my gosh. I can't write though, so who might have talked? 3x minus 1. There we go. So that's really my denominator here. And you might be curious why there's parentheses around this numerator. That's because of that guy right there. We need to make sure that we're distributing the subtraction. We're not ready to distribute yet. Hang tight. Let's talk about our common denominator. A listing of everything I see that shows up in the denominator. So this guy has a 3x minus 1, and this guy has a 3x minus 1 and a 3x plus 1. So if I make my shopping list, I need a 3x minus 1, and I need a 3x plus 1. Which is good news, because this fraction right here is okay. It's good to go. It's not missing anything, but this fraction is missing the 3x plus 1. So, my numerator is kind of messy right now. I have let's see here, a 5 times a 3x plus 1. So that would be a 15x plus 5. And then I have a subtraction sign that has to be distributed to the 7x minus 4. So even though we didn't have to multiply that by anything, we do have to distribute the subtraction. So it's really a minus 7x, and this becomes a plus 4. So after we simplify and collect our like terms here and here, what do we get here? That's an 8x plus 9, which doesn't factor. That makes me so happy. 3x minus 1 times 3x plus 1, any order on that denominator. What I do like about this section is once you come up with that common denominator, you don't have to do any more work to it. Like, you just have to kind of keep carrying it through your work. So if you can get around the common denominator concept, then you're good to go. And if that's where your issues are, then that's what we'll work on, you know, for remediation. But hopefully we don't have any issues. That'd be great. All right, so they want to know what are the excluded values. So remember, excluded values are things that x cannot equal. So we can't divide by 0. That's the major problem. So I look at all my denominators and I think about numbers that would make them come out to 0. So you can set up anti-equations. You can say x minus 9 cannot be 0, and you can say x squared minus 81 cannot be 0. And you can solve them just like you would an equation. So this one, if you add the 9 over, you get x cannot be 9. And then this one, x squared minus 9, you can either square root or factor that one. That one factors pretty nice, right? X plus 9 times x minus 9 can't be 0. So that gives me two things that x can't be. X can't be positive or negative 9. So this was kind of a weird question because that 9 was excluded for two different fractions within the problem. It doesn't matter. The whole point of this is, after I go through all my work, if I was going to solve this, if I happen to get 9 or negative 9 as my answer, I'd have to cross it off. Alright, so that's just a vocab question. You don't actually have to solve the question. Ooh, thank you. But now you do. So, first step says factor any denominators, and remember your tests are going to be highlighted with anything that has to be factored. So nothing's going to be highlighted here, which means I'm ready to come up with my LCM. So the LCM is a listing of everything you see that shows up in a denominator, and the monomials are the parts that mess with kids, because I have an x, a 2x, and an x plus 1. So I see an x plus 1, but let's talk about the x and the 2x. Sometimes kids tell me, I need a 2x and an x, and I go, that means 2x squared, and I don't see an x squared anywhere. So then you got to think a little smaller. You just need a 2x. Yeah, you don't need this extra x. It's weird. Because x is a component of 2x. Monomials are kind of nested within one another, so we have to be careful about that. So our LCM that we're going to multiply into every term is a 2x times an x plus 1. So remember, these are the ones where I suggest, because you guys are real new to this, I suggest you write it out the long way, even on your test, which means you're going to write your LCM in front of every fraction, and you're going to multiply them together in a minute. I know some of you were like, oh, but there's a shortcut. I know there's a shortcut, but I also know what these tests look like. So maybe don't take a shortcut, because I wrote them. All right, 6 over 2x. Whoops, sorry about that. It's not very pretty. Equals, and then LCM one more time. Ugh. Times the last fraction. Change to black. There we go. 3x over x plus 1. So then what I usually do is I put a box around each multiplication question. That way I can focus on cancellation. There should be a lot of cancellation on these questions, guys, because we can't have denominators. That's why we're doing this LCM trick. Some of you found out through your work that if you don't pick a big enough LCM, you end up with all your denominators not canceled. So that tells you you weren't very wise with your choice of LCM, and you have to go back and revisit that step. All right, so here the x is going to cancel with this x, but you still have a 2 times x plus 1 times 7. We'll come back to that in a moment. Here the 2x cancels with this 2x, and here the x plus 1 cancels. Alright, so this box, 2 times x plus 1 times 7. When you have three things multiplied together like this, you have to do them in stages. So I'm going to choose to multiply the 2 and the 7 together first, and call that a 14 times x plus 1. I will distribute that next. Alright, so here you have a 6 times x plus 1. Again, I'm going to distribute that next. Ah, that's a plus sign, Abruzzo. Come back. You can't have two equal signs. Doesn't make sense. All right. Plus.
So this last box here is 2x times 3x. Ugh, that's awful. It's a quadratic plus 6x squared. Alrighty, here we go. Let's distribute 14. So I have 14x. This is probably more elaborate than the one you're going to see in your test, so don't panic. I'm not saying you can't have a quadratic. Quadratics are fine, but this one has a lot going on. Alright, I see it's a quadratic, which means everything has to come to one side. I'm going to choose to bring everything to the right, because that would allow me to have a positive quadratic term. And then, I'm going to get a little crafty here. I'm going to reverse the order of some of the terms. Like, obviously this term would come first in a quadratic. And then this term would be next, so that's what, a negative 8x? And then the constant would be last, so that's negative 8. And I notice this quadratic in particular can be divided by 2, so I'm going to go ahead and do that, because that seems like it would make my life easier. So we end up with 3x squared minus 4x minus 4 equals 0. And I guess I'm going to factor that. Here we go. Oh boy. Alright, 3x and 1x. 2 and 2 will work, because if you make this a negative 2, and make this a positive 2, you get negative 6 plus 2, which is how I'm going to get negative 4 in the middle of the arches. Alright, but you're not done. You got to solve, right? X equals, let's see this solution to this one. Not skip a step for you. So 3x plus 2 could be 0, which would give me, let's see, subtract 2, divide by 3. So negative 2/3, and then x equals 2. And I kind of forgot a very critical step here. I'm going to box these in, but I'm going to go back and make sure that neither one of these would give me a divide by 0 with those extraneous solutions. So plugging in a 2 here, here, and here, that's good. Plugging in a negative 2/3, also good. So I'm going to keep both answers. I think these would be good ones for you guys to practice. This was the most recent thing we learned. That's kind of tough. Alright, on your test, this would have been highlighted. So we're going to factor x squared minus 9 into x plus 3 times x minus 3. So when I go to make a list of my LCMs, I see an x plus 3 and an x minus 3 that I need to get rid of. So that's what I'm going to multiply in front of each term. So I'm going to take a bit of a shortcut on this one for the sake of space and time for us. I'm just going to write down what doesn't cancel. So on this first fraction, x plus 3 times this fraction, the x plus 3 and x minus 3 will both cancel, which leaves me with just the 18. Now the 1 has nothing to cancel with the LCM, so the 1 is still being multiplied by x plus 3 times x minus 3. So I'm going to leave the 1 off if you don't mind, because 1 doesn't do, like if we put a 1 here, it's not going to do anything. And then this last fraction, x plus 3 minus 3 times this fraction, the x minus 3's will cancel, and you still have a plus 3 times the x plus 3. Alright, so a little distribution, let's solve. 18 equals, let's see this term, oh that's nice, that's x squared minus 9. And then distributing this gives us plus 3x plus 9. So we do have a quadratic. These kind of cancel each other, but if I subtract the 18 over, I get 0 equals x squared plus 3x, now it's a minus 18. That's a pretty basic factoring. How about x plus 6 times x minus 3? And again, gotta solve. So I get x equals negative 6 and x equals positive 3. And I'm so excited to get two relatively nice answers that I probably am going to forget this next step. Remember, we have to check for excluded values. 3 is going to be a problem, because look right here. If you plug in a 3, you get 3 minus 3, which is 0, which is a divide by 0. So what you're going to have to do is cross it off, write extraneous, or some abbreviation for extraneous next to it. Negative 6, however, works, because that wouldn't give you a divide by 0 anywhere. So you get to keep that answer, but this one's extraneous. If you go through your work and your only answer that you get is extraneous, that means there's no solution. So keep that in mind. Hint, hint, it might show up. Alright, 18. This is a proportion, so a lot of us are going to be tempted to just cross multiply. So while we could cross multiply this question, I might suggest you follow your yellow sheet's steps, because this factors right here. This is x plus 4 times x minus 4. So if you use the LCM technique, the LCM on that question is that, x plus 4 and x minus 4. And you're going to end up with a lot less work. So if you avoid your middle school instincts to cross multiply, look what happens here. This fraction, the x minus 4s would cancel, and you're just going to be left with 1 times x plus 4. And then this fraction, both the x plus 4 and x minus 4 will cancel, and you're just going to be left with 2x. Much easier equation to solve versus someone who cross multiplied. If you were to cross multiply this equation, you would have ended up with pretty intense quadratic. Still not done. And the quadratic would have had some extraneous solutions, but fun fact, we also have an extraneous solution, because x equals 4, look right there. If you plug in a 4, 4 minus 4 would be divided by 0. This is extraneous, which means since our only solution is bogus, there is no solution. Alright, good luck.